Hi, in today's video I would like to introduce you a very nice and interesting equation of Estonian Mathematical Olympiad edition 1998. Our goal, we are going to solve the following equation: x squared plus 1 equals log of the base 2 of x plus 2 minus 2x. Okay, in fact this is very nice problem, but they didn't even tell us which set we can solve this equation. Okay, we don't even know how we're gonna deal with this variable x. Okay, so they leave it to you guys to figure out which set. So along the way we are going to figure out which set we can choose. Okay, so I'm trying to give you the hint for this problem, but it's very limited. So just start solving this equation when you get to some point and figure out how we're gonna deal with that expression you will find. Okay, so go ahead, pause this video if you would like to give it a try to this problem. When you come back to see the full solution. Okay, let's get into the solution. So we have the following equation. We have x squared plus 1 equals log base 2 of x plus 2 minus 2x. Okay, this equation, if it's not a real number, it will be the integer. Okay, so always we have to keep inside of the log is positive number. So this one for all, so x plus 2 must be strictly superior than 0. Okay, so in the other word, x must be strictly superior than minus 2. Okay, so we are going to work on this interval. Okay, I'm going to solve this equation normally. I will have x squared plus 1 equals this one log of x plus 2 is divided by log of 2. This is the log rule. If you have the base here, you have to do log of x plus 2 is divided by log of 2. Okay, minus 2x. So I'm going to make log 2 as a common factor and divide side by side to see what's given us. By multiplying this one by this one, I will get x squared plus 1 is multiplied by log of 2 equals this one log of x plus 2 minus 2x is multiplied by log of 2. Okay, so basically this one, it was log of 2 to the x squared plus 1. After simplification is giving us this one. The same thing with this one, it was log of 2 to 2x. Okay, so this one is giving me log of 2 to the x squared plus 1 equals log of x plus 2. I'm going to leave this one as is it, minus 2 to the power of 2x. Okay, I'm going to bring this term to the left hand side of this equation. I will get log of 2 to x squared plus 1 plus log of 2 to the x equals log of x plus 2. Okay, I'm going to put these two terms together inside of log. I will have log of 2 to x squared plus 1 is multiplied by 2 to the x equals log of x plus 2. Okay, I'm going to apply the exponential rule here. This one is giving us log of 2 to the x squared plus 2x plus 1 equals log of x plus 2. Okay, this is the form quadratic binomial. This one equals x plus 1 quaternary square. Okay, I will be ended with the expression of log of 2 to the x plus 1 quaternary square equals log of x plus 2. Finally, I will end with the expression of 2 to the x plus 1 quaternary square. By taking the log function out of these things, I will get this one equals to x plus 2. Here is the final expression of this equation. I'm going to clean up this board and bring this one at the top and continue solving this equation. Okay, in the last board I was working on this equation and came up with this expression. This is the most confused point for this equation. If the solution of this equation is not an integer, is a problem. So if the solution is an integer, we are allowed to apply the arithmetic rule here. Okay, the problem how to factor out this one. Okay, so on the left hand side of this equation we have x is located in the exponent, we have x in the base. How to maintain this equation and make it more reduced? Okay, so the first thing we are going to do, so we are going to consider x is an integer. If we find our solution as an integer number, we are good, but if the solution is not an integer, is a problem. Okay, we have x strictly superior than -2. I'm going to put the substitution x plus 1 quantity square equals 2y. Okay, as we know, this one is superior or equal to 0 because this one is positive. That means y is positive as well. Now I'm worried to solve this equation. Now I will have a new equation in terms of y. I will have 2 to the 2y equals, as we said here, this one is equals x plus 1 plus 1. So the problem, how to replace x plus 1, x plus 1. So I'm going to replace x plus 1. Be careful here. This one you will take two choices. X plus 1 is, you will take square root of 2y, and the second one take minus square root of 2y. Because if x plus 1 was positive, I will be end with square root of 2y. If x plus 1 was negative, I will be end with this one, minus square root of 2y. Okay, so I will have two equations here. First one, 2 to the y, I will have square root of 2y plus number 1. The second equation, I will have 2 to the y equals minus square root of 2y plus 1. Okay, now I'm going to bring this one to the left hand side of this equation. I will get 2 to the y minus 1 equals square root of 2y. The second equation, I will have 2 to the y minus 1 equals minus square root of 2y. Okay, I'm going to prove the second equation is not valid anymore. Notice here we have 2y is superior or equal to 0 as we have here. Okay, I'm going to raise this one on form of the exponent. I will have 2 to the y is superior or equal to 2 to the 0, which equal to 1. Okay, I'm going to bring this one to the left hand side of this equation. I will get 2 to the y minus 1 is superior or equal to 0. Okay, so if you take a look carefully, we have this term is superior or equal to 0, but this term is strictly inferior than 0, which is impossible. Okay, we have this one positive with this minus sign, negative. This one is positive, which is contradiction. That means this choice is a ruling out of this possibility. So I'm going to take only this equation. I will have end with this expression of 2 to the y minus 1 equals square root of 2y. Okay, I will end with the expression of 2 to the y minus 1 equals square root of 2y, with y is superior or equal to 0. Now this one is very clear. I can factor out this one. This one is giving us 2 to y minus 1 factor 2 to the y plus 1 equals square root of 2y. Okay, since x is an integer, that means y is an integer as well, but y must be positive. Okay, here is a problem. So I'm going to apply the arithmetic rule since we have the integers. Okay, and to see what's given us. Okay, if you take a look carefully at the expression of the left hand side of this equation, this is odd. Okay, this is odd as well, because 2 to the y is even, plus 1 become odd. The same thing with the left hand side of this product. 2 to the y is even, minus 1 is odd. So both terms are having the same parity. Okay, so the right hand side of this equation must be odd as well, but 2y is not odd, is even. Okay, we have two conditions here. We must have this term odd, and also we must have this one as a perfect square, which is impossible. Okay, To have this one a perfect square first, y must take these values. To get y out of this square root, y must take these values. First one must take 2 to the 1 is taking following numbers. Y must take 2 to the 3, or y is take 2 to the 5, and so on and so forth. Okay, is taking this form, because if y equals 2 to the 1, that's mean to y you will 2 to the 2, which 4 is square root of 4 is given as 2. Okay, for 2y, for the second case, y equals 2 to the 3, that's mean 2y equals 2 to the 4, which is 16, square root of 16, which is 4. For the third choice, y equals 2 to the 5, that's mean 2y equals 2 to the 6, that's mean 64, the square root of 64 is 8, and so on and so forth. Y must take this pattern all the way down, but this pattern is an even, but we need the odd, okay, which is contradiction. Y has no choice to be odd. The only y tick is ticking 0. Okay, y must be equal to 0, because there is no choice for that. Since the right hand side of this equation is equal to 0, that's mean the left hand side of this equation must be equal to 0 as well. But this term is not equal to 0, is a positive, because this one is a positive number, plus 1 is strictly superior than 0. This one must equal to 0. Okay, so this one equal to 0, that's mean 2 to the y minus 1 equal to 0. That's mean 2 to the y equals 1. That's mean y equals 0. Okay, that's what we have here. So y equals to 0, we have the substitution. We put x plus 1 quinary square equals to y, which equal to 0, implies x plus 1 equals to 0. That's mean x equals to minus 1. Okay, so we found the solution of this equation, x equal to minus 1. Okay, now we found the solution in integer. If you want to take this value as a real number, you can take it, because the real number set is more powerful. If you try to plug this minus 1 into this equation to see your equation is verifying this solution or not, I'm going to check it. I have minus 1 quinary square plus 1 equals natural log of minus 1 plus 2 minus plus 2. Okay, because minus 2 is multiplied by minus 1 is given as plus 2. So minus 1 quinary square is 1, plus 1 is 2. For the right hand side of this equation, natural log of minus 1 plus 2, which is 1, natural log of 1 is 0, equals to, that's mean the left hand side equal to the right hand side. That's mean this equation is verified, this solution. So I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. If you have any question or suggestions, just put it in the comment section below. Thank you for watching. I will see you in next video. Bye.